Our question is there are two coordinates a 2,2, b 4,2 on the coordinate plane. Solve for a domain of a which makes the segment AB intersect with the quadratic function y is equal to ax squared plus 2ax plus a minus 2. So this question is basically asking us to solve for the variable, the domain of the variable a. And the a will going to be the variable which changes depends on times. And the a which makes the two functions intersect together on the coordinate plane. So we have our three solutions for solving this kind of questions. Firstly, let's think about the types. The first solution to approach this question, types and definition of vertex in the quadratic function. And we can think about the definition of the vertex through the types of it. And luckily, they are all defined by the leading coefficient a in the quadratic function form. And if you don't know what the leading coefficient is, let's go back to our standard form, which is the most basic format in the quadratic function. So our standard form will going to be y is equal to a x squared plus bx plus c. From here, let's think about what this each variable does or what this each variable defines. Standard form will going to be our first situation or solutions, and the first thing that we're going to talk about we're going to be what is the y next. The y should always be some specific output, and in order to be the output should be generated by some specific input, and we notate it as the x value. So y should be output and x should be input of specific functions. And secondly, let's think about what does each variable does except a, x, and y. And the first thing that we can think about, what does a does? And a, first of all, it is a leading coefficient. A is a leading coefficient. And the difference between just a coefficient and if you don't know what the coefficient is, it is just a normal numbers beside the variables. And the only difference between coefficient and just a leading coefficient will be defined by the word leading. The word leading is a short form to refer to the highest degree power leading term of our quadratic function x squared. And the coefficient of the x squared term, which will going to be the highest power term, will going to be the a in this case. So the a. So our a will going to be the leading coefficient. Let's think about the second one. Our second one, so we're going to be our third one. Our third one is what is the b? B is exactly the same kind of concept with the a, except it is just a coefficient. It is the coefficient of the first power degree term x. And lastly, let's think about what is the c. C will going to be our y-intercept in our standard form. And if you don't know what the y-intercept is, if we convert this into some specific coordinate, it will going to be 0, comma, y. Which means when our input value, our x value is equal to 0, our output of our function, which will going to be our y value, will exist. And the reason why we notate it as the y value, not a specific value, is because we know that output and the input, which will going to be x and y, are all variables, which means they changes or varies depends on times. So we just notate it as the x or y. Let's think about the two cases of our quadratic function's vertex that we're going to be defined by our leading coefficient a. The first case of our quadratic function's vertex we're going to be defined when our a value, our leading coefficient, is greater than 0. Which means when it is a positive value, the graph of our quadratic function will opens or go upward. And when the quadratic function's graph opens upward, for example, it will look something like this. That keeps going to operate, never intersects at one point. But then it will contain another most important point or a thing in our quadratic function, which we call it as the minimum point, as well as the lowest point on our quadratic function's graph. And this will occur when the a value, our leading coefficient, is greater than 0. Our second case of our vertex, when it will happen when our a value, our leading coefficient, is negative value. Then the graph of our quadratic function will open or go downward, unlike the first one where it went upward. When the quadratic function's graph opens upward and downward, the downward will look something like this, that is opposite with the first one going upward, and it will contain another most important point in our quadratic function, which we call it as the maximum or the highest point on our quadratic function. And this will occur by our leading coefficient signs. And from here we can think about the definition of the vertex in our quadratic function through its types. Our definition of the vertex will going to be the addition of between the number of possibilities between the minimum point and the maximum point, which means a vertex contains the value, the number of possibilities of the a, which will going to be our leading coefficient. And these things we talked about what is the vertex through the standard form, which will going to be the basic format or the form in our quadratic function, as well as the types of our quadratic functions, vertex. Let's think about the second solutions to approach these questions. General three types of quadratic functions form. So there are generally three cases or the types that we use in the quadratic functions. And they have they're all optimized for solving for something, and they will going to be the standard form. So the standard form, binomial form, and lastly, it will going to be a vertex form. And we're going to talk about what each forms of our quadratic functions are optimized for. Firstly, let's think about the standard form, which is the most basic format of the quadratic function. The format will going to be y is equal to a x squared plus bx plus c, as we have talked about. Basically, standard form is optimized when it comes to solving for the calculations, the basic calculations. So the standard form is optimized for the calculation to solve for the missing or unknown variables, as well as the y-intercept. And y-intercept is one of the variables that we can solve through the calculation in the standard form. But one thing that is bad about the standard form is that we know that the vertex is the most important thing in a quadratic function to complete our drawing or the parabolas. But for the vertex, every single coordinates on the coordinate plane can be summed up as the x, y, where x is input and y is output. But for the standard form, we can't draw a parabola. The reason is because there is no way to solve for our x and the y. All you have to do is convert this into some specific format, or we need to convert this into some specific format, or convert this into a specific formula that we can apply to solve for a vertex. Now let's go back to the second one, which will going to be our binomial form. Binomial form is optimized for solving for the x-intercept. If you don't know what this x-intercept is, it is exactly the same kind of concept with the y-intercept, except the thing that is 0 will going to be our output y, and our x value input exists. And also, unlike the standard form, we don't have to convert this into some specific formula to solve for a vertex. The reason is because we know that according to the property of our binomial form, so there is a x and a y for our vertex, and our x value, which will going to be our input of our function, is exactly the same thing with the mean, or we call it as the average. So it is the average of two x-intercepts. And this is one of the property of binomial form and one of the convenience things about the binomial form. We don't have to convert this into some specific format, unlike the standard form. It is exactly the same thing with the average of two x-intercept, which means in order to solve for our x, which is the input, all you have to do is add all of the x-intercepts, so all of the x-intercepts, and divide them by the numbers that will usually become 2. Then we're going to be able to solve for our x value, which will going to be our input of our functions. And since we solved the input value, all you have to do in order to solve for the output is to input our specific value to our original function. This is how the binomial form works. And lastly, let's think about the vertex form. The format of our vertex form we're going to be y is equal to a times x minus p squared plus q. And as we can see from its name, it is optimized for solving for the vertex of some specific function. The reason is because the vertex, we also know it as the x comma y, but in this case our p value we're going to be our input x value of our vertex, and our q value we're going to be our output, our y value of our vertex. So vertex form is mainly optimized for solving for the vertex, which is the most important thing that will occur or be existed by our leading coefficient a. So these were the solution to which was thinking about the general 3 types of our quadratic function. Let's actually approach our question and we can think about the last property, which we're going to be what is the domain and the range of a specific format or the function through our solving the questions. So our ultimate question or the answer in this question, we're going to be solve for the variable a, which defines our two functions intersects together. Let's write our function down, which we're going to be y is equal to ax squared plus 2ax plus a minus 2. This will going to be our quadratic function, which means when you convert this into a specific graph, we're going to get a parabola that satisfies our equation. So actually, let's simplify this into our vertex form, which is optimized for solving for our vertex to think about the basic graph of a function. And we know that for solving for a vertex form, it is the same thing with completing the square. So if you think about our function here, y is equal to ax squared plus 2ax plus a minus 2, we can simplify. All of them are divisible by a except for negative 2, so we can kind of change it here. If we convert this into some specific format, so first of all, we're going to be y is equal to ax squared plus 2ax plus a minus 2. And this will going to be y, or we could just write it down, a times x squared plus 2x plus 1 minus 2. We are completing the square. And lastly, if you write in different color, this will going to be y is equal to the final vertex form a times x plus 1 squared minus 2. So as we can see, let's apply our properties of our vertex form. Our vertex of our function, we're going to be negative 1, comma, -2. So before we think about how to approach this, let's think about the domain and the range. And they're all about the range. There are two ranges. There are domain, first of all. If you don't know what the domain is, it will going to be a range. So the domain is the range of x values. Now let's think about what the range is. Our range will going to be the range of y values. This is what the domain and the range definition is. In this case, the a, which we're going to solve, will going to be the domain. But in this case, the domain doesn't work in this question because there is the x value and there is the y value. So they're just telling us to solve for a domain or the range of our a value, and it doesn't matter because it is not the x or y. So, but as we can see, domain, or will going to be some numbers between two numbers, and the two numbers will going to be either minimum values or the maximum values. So let's actually get through it. So as we can see, this function passes through the 2 points a, and the a value will going to be 2, 2, and our b point, which will going to be 4, 2. So this function passes through this 2 points, a and b. A and b are the only given points, which means the point A and the point B should be either minimum or the maximum values that A can be. So let's make a line to be clear about this. First case, we're going to be when we input the value as the A value. When you input A value, first of all, we know that the coordinate of the A will going to be 2, 2, which means when our x value, our input equal to 2, our output of our function, which we notated as the y value, should always be the output 2. And they're all going to be 2. So let's write our function down, which we convert as the vertex form. Y is equal to a times x plus 1, x plus 1 squared. So a times x plus 1 squared minus 2. So we're basically inputting 2 and a 2 into our function, which will going to give us y is equal to a times 3 squared minus 2, and that is equal to our output 2. So if you simplify this expression, we'll end up getting the our first a value, and before that we're going to get 2 is equal to 9a minus 2. And from here, we'll be able to isolate our a value and solve for our first a value through our input value. And our a value from our input a will going to be 4 over 9. So this will going to be our first case of our a value, and we don't know if that will going to be the minimum or the maximum point. So this can be either minimum or the maximum value. So we can know if it is minimum or maximum value through the second case, where the input value changes as b. And our point b is exactly the same with point a, except the x value, 4, 2. So let's write our function down again. Y is equal to a times x plus 1 squared minus 2. When we input our 4 into x value and output as 2, we're going to get 2 is equal to a times 5 squared minus 2. And if we simplify this, we'll be able to isolate our a terms. And we're going to get 2 is equal to 25a minus 2. And from here, we'll be able to solve for another a value, which will going to be 4 over 25 as we simplified. So 4 over 25 will going to be our second value that a can be. And this also can be either minimum or the maximum point. So our answer for this question, the a value should always be the middle. And we know that it should always include those two values. And from the left side, there should be a minimum value. And in the right side, there should be a maximum value. And the maximum value will gonna be the biggest, and the minimum will gonna be lowest. And as we compare these two things, we know that 9 over 4 is way bigger than 4 over 25, 4 over 9. So our maximum point will gonna be 4 over 9. And the a can be either equal or less than 4 over 9. And our minimum point, minimum value, 4 over 25, which means the a value can be either greater or equal to 4 over 25. And this domain, so this domain of our a value will going to be exist. And this will going to be our final answer. To review what we did here, we talked about the three solutions to approach this question. In our basic ultimate question was the solve for a domain of the variable, and the variable in this case was a, which makes these two functions intersect in the coordinate plane together. So firstly, we talked about the types and the definition of the vertex. And we could figure out that they have their own possibilities where the a value signs exist. And then we talked about general three types and what it is optimized for, and there were standard form, binomial form, as well as the vertex form. And the standard form was optimized when it comes to solving for the calculations and the y-intercept, because y-intercept is one of the calculations that we can use. Secondly, but before we do that, we know that standard form was not convenient for solving for the graphing the parabola, because we couldn't solve for the vertex x, y, which is the most important point when it comes to graphing a parabola. Secondly, for a binomial form, it was y is equal to a times x minus p times x minus z, and it was optimized when it comes to solving for the x-intercept, because it was formed by the x-intercept. And also, one thing that is convenient about the binomial form is we don't have to convert this into some specific format or the formula to solve the vertex, because we know that every single point in the coordinate plane is x, y, so do the vertex. And the input value or x value should always be the mean, or we call it as the average of two x-intercepts. So for a vertex form, as we can see from its name, it is optimized for solving for the vertex of a specific function. Now we actually solve for our question. All we did here is the only reason why we convert this into a vertex form, because it is a convenient for this, because if you just solve through our original function, y is equal to ax squared plus 2ax plus a minus 2, it contained 1, 2, and 3 variables, which made the calculation difficult. But by making our vertex form, we removed it into 1. We unified it into 1. And we talked about what is the domain and the range, which was the ultimate question in this problem. And then we talked about the two cases as they offered us two coordinates. And then we could figure out our answer. The a value, which is the domain of the variable that makes the two function intersects on the coordinate plane. The a value can be either greater or equal to 4 over 25, as well as the a value can be either greater, less, or equal to 4 over 9.